Imagine this: a serene stretch of darkness, infinite in every direction, pierced by glowing tendrils of plasma coiling like celestial serpents. Stars drift in slow, dignified motion across a canvas of velvet blackness. Then suddenly a curve, not of a planet or a moon, but of something unseen, something incomprehensibly massive, distorting space itself, a ripple in reality, a silent shudder in the void. Could something like this be hiding in our own solar system? It's a question that grips the imagination and tightens the chest. Black holes, those silent monsters of gravity, have long felt like distant threats, nestled in far-off galaxies, tearing stars apart in brilliant, fiery deaths. They are dramatic, exotic, and impossibly far away. But what if we've been wrong? What if one of them is close, hiding, waiting, watching? The idea is not science fiction. It's a possibility grounded in the cutting edge of astrophysics. And to grasp how serious this question has become, we have to journey back not just decades, to the birth of time itself. In the first seconds of the universe, when everything was new and wild and unknowable, matter and energy churned like a furious storm. Quantum fluctuations danced through the hot, dense fabric of space. Some regions became just dense enough to collapse not into stars or planets, but into singularities. These were not the hulking beasts born from dying suns. These were primordial black holes, smaller than an atom in size, some of them, but impossibly dense. Some could weigh as much as an asteroid, others perhaps more. These strange relics, if they exist, are older than galaxies, older than light itself as we know it. They could be drifting through the universe, even now, billions of them, cold, silent, and completely invisible. For years, the idea seemed too speculative to be taken seriously. But then came a problem too big to ignore: dark matter. The cosmos, as it turns out, is mostly made of something we can't see. Dark matter exerts gravity, shaping galaxies and bending light. But it doesn't glow. It doesn't interact with ordinary matter. It just is. And no one knows what it's made of. So, when physicists revisited the idea of primordial black holes, it was not just curiosity, it was desperation. What if these ancient objects were the missing mass? What if we had been swimming through a universe full of them, without ever knowing? While theorists worked on models and simulations, space agencies hunted for clues in the stars. In 2023, ESA's Gaia spacecraft made headlines. It had detected the subtle dance of a nearby star wobbling in a way that could only be explained by the invisible pull of a black hole. That object, dubbed Gaia BH1, became the closest known black hole to Earth, just 1,560 light-years away. A cosmic neighbor in galactic terms. But that was only the beginning. In 2024, two more joined the growing list: Gaia BH2 and BH3. The latter turned out to be a colossus 33 times the mass of our Sun, drifting silently through space. These discoveries changed the game. Black holes, once thought to be rare and far away, were now proven to be much more common, and they could be closer than anyone had imagined. Even so, they were still distant, light years away, harmless. But there was a catch. All of those were stellar black holes born from the depths of stars, the kind that announced their presence with radiation and fire. Primordial black holes are different. They are silent, they are invisible, and they don't follow the same rules. If even one of them was moving through our solar system, we might never know unless we were paying very, very close attention. This is where the story shifts from distant astronomy to planetary science, to Earth itself, and to the sensitive instruments we have built in orbit around our world. Over the past few decades, human technology has reached an astonishing level of precision. Satellites orbit Earth within millimeters of predicted paths. Mars rovers report their positions with unmatched accuracy. The supple wobble of a moon or the tug on a spacecraft can be measured, cataloged, analyzed. And now, scientists are using that data to look for ghosts. The theory goes like this: if a primordial black hole the mass of a small asteroid passed through the solar system, it would warp gravity around it. Not enough to cause disasters or collisions, but enough to leave behind a trail: microscopic changes in orbits, deviations in timing, unexplained anomalies. These would be easy to overlook unless you were searching for them. So researchers have started to look, really look. They are reanalyzing decades of orbital data from satellites around Earth and other planets. They are feeding this data into simulations that model what a black hole flyby might look like. They are comparing planetary motion against models with and without such encounters. It's painstaking work, like trying to find a fingerprint in a snowstorm. But they're finding patterns, strange ones. What if one of these is real? Imagine it, a black hole no larger than a marble, weighing as much as a mountain, passing through the space between Earth and Mars. No light, no explosion, just a brief encounter. And in that moment, gravity bends in a way it should not. A satellite veers slightly off course. A planetary orbit shifts by a fraction of a degree. It does not make the news. It doesn't even raise alarm. But the data is there. And someone, somewhere, is paying attention. Now picture the year 2032. A team of scientists at NASA and the Paris Observatory make a startling discovery. They have been analyzing long-term deviations in multiple spacecraft trajectories. At first, nothing unusual. But then, a pattern emerges. Deviations that seem random start to form a curve. That curve matches what you would expect if a primordial black hole had passed through the solar system in 2028. The simulations confirm it. They publish the results. The world reacts. Telescopes pivot. Gravitational wave detectors reprocess their archives. Theoretical physicists scramble to update their models. For the first time in history, we may have witnessed the passage of a primordial black hole not in science fiction, but in real time. And with it, we may finally understand a piece of the dark matter puzzle. Or maybe the pattern is just noise, coincidence. The universe, after all, is full of tricks and illusions. Science advances slowly, not with fireworks but with patience. Even if no black hole is found, the search itself brings progress, better models, more accurate instruments, deeper understanding. And maybe, just maybe, the next one will be real. Because the truth is, we are living in a moment of discovery. The universe is not silent, it's whispering. In data, in motion, in gravity, we just have to learn how to listen. Even now, as you read this, something might be passing through the outer solar system, a traveler from the dawn of time, unbound by light, unwatched, yet leaving behind invisible waves in the sea of space. Are there black holes in our solar system? Maybe, maybe not yet. But the evidence is mounting. The tools are sharpening. The question is alive, and the hunt is on. So the next time you look up at the night sky, remember, the cosmos doesn't just lie above us. It flows through us, around us. Its ancient secrets are moving right now, hidden among the planets, tucked between the stars. If you found this journey through cosmic shadows as thrilling as we did, don't let it end here. Smash that like and subscribe button. And if you are curious what's lurking in the silence of the universe, hit subscribe and turn on notifications, because the next black hole might be closer than we think. Until next time, keep watching the stars. They might be watching back.